Hello and welcome to our first video lesson for week 2. In this lesson we're going to talk about the primitive data types, the data types that are built into Python to let you work with numbers and strings of characters. A lot of this is going to be similar to what you've done in other programming languages, but there are a few important differences. So let's get started. Okay, let's start with numbers. In Python, numbers can either be integers, that is whole numbers, no decimal digits, or floating point numbers. They can contain decimal digits. Unlike in many other languages, Python doesn't require you to explicitly declare the type of your variables. The first time you use a variable, it gets assigned a type based on whatever the value is you gave it. If you say something like x equals 17, it says, oh, that's an integer. And if you later on say x equals 17.5, it will say, I'm now going to store it as a floating point number. Very different than languages like Java and C++, in which a variable has one type that has to be explicitly declared, and it keeps that type forever. Here's some examples of numbers in Python and ways you might specify them. -3 or 15 or 617, or something with a decimal point, 0.004167, or a negative number with a decimal point. Or we can even use scientific notation. This means 5.678 and so on times 10 raised to the 25th power. This little e here is the signal to Python that you're using scientific notation, means 10 raised to a power. It's not the same as the little e you may have learned in a pre-calculus or a calculus class as the base to the natural logarithms. It's just 10 raised to a power. So let's keep going on to our next slide. How big is the biggest number you can store in Python? Well, for an integer, there is no biggest number you can store. You want to type something in that has 35 digits or 70 digits, that's fine. Python can handle it. Integers can be as big or as small as you want. No explicit limit. For floating point numbers, there is a limit based on the way floating point numbers are represented inside the computer. And the largest value, or the largest absolute value you can store, is about 1.8 times 10 raised to the 308th power. That's like a 1 with 308 zeros after it. It's a pretty darn big number. It shouldn't be much of a problem for you. And the smallest value that you can represent, other than 0, is 2.22 times 10 raised to the minus 308 power. That is 0.307 more zeros, 222507, and so on. Or, of course, you can set something exactly equal to 0, and you can use negative numbers. You can get about 15 significant digits of accuracy. In addition to numbers, integers, and floating points, Python has a way for you to keep track of logical values, true and false. They're called Booleans in Python and in many other programming languages. In Python, this Boolean value is abbreviated as BOOL. We'll see a function later on called bool that lets us manipulate values like this. There are only two values you can represent that are Booleans. They're called true and they're called false. Notice they have an uppercase initial letter and the rest of it is lowercase. That's important, and we'll see it when we do an example of typing some things in Python. You can also have strings in Python. Strings are sequences of character values. You specify strings by enclosing characters in either double quote marks or single quote marks, apostrophes. So here's some examples. Hello, blue. It's cold in here. Notice that's a way for me to put a single quote inside my string. This is a double quote. I can now put a double quote inside a string. Quote 15 quote is the character string 15. It's not the number 15. You can't do arithmetic with it, but you can use it as a character string. And I can put true in quote marks. It's now the characters TRUE, not the logical value true that we learned about when we talked about Booleans. There are some characters that you might want to include in a string that are hard to type, so Python provides escape sequences. These are exactly the same as in many other languages like Java, JavaScript, C++. Each escape sequence starts with a backslash character. Some of the most useful ones are \n to get to a new line, \t to execute a tab, \\, if you ever want to include the backslash, like say as part of a file name. Single quote gives you a single quote, double quote gives you a double quote. So here's an example of using that. I could do print hello, tab character, Mr. I, new line character, it's a nice day. And that will do hello, tab over to the next tab space, Mr. I, go to a new line and do it's a nice day. We can convert from one type to another using the built-in functions str, int, float, and bool. These attempt to change values from one type to another, as long as it's something that Python can figure out what you meant. And it will give you an error if Python can't figure it out. So here's some examples. str15 gives me a string that has the character value as if I had typed in quote 15 quote. Float 15 is the same as if I did 15.0. Int 15.0 is the same as if I just typed in the integer 15. Int 15.3 gives me just the integer part of that floating number. That gives me a 15. Int quote 15 quote is the same as 15. Int 15.3 in quotes gives me an error. If I have a string that's got a decimal point in it and I try and turn it into an integer, it will fail. Now I could do float quote 15.3 and that would turn it into a number. Integer of something that doesn't look like numbers at all, like A, B, C, D, E, F, G, gives you an error. Bool of 0 gives you a false, and bool with any other value gives you a true. Okay, we're ready to hop into Python's idle program. Try a few of these things out. Here I am in the Python shell from idle, and we're going to play around with different types of variables, the different primitive types, the numbers, booleans, and strings. So I'm going to say x equals quote Mr. I. If I print x out, I get Mr. I. If I want to know the type of x, I do type x and it says, oh, it's class str. If I do a string of x, I get Mr. I. Okay. Suppose I now have a variable y equals is a heck of a guy. I think you can see where I'm going here. Now, what happens if I try and print out x comma y? Mr. I is a heck of a guy. Or I could do print x plus y. Mr. I is a heck of a guy. What's different? Two spaces here when I just printed out x and y, because print says print the value of x, do a space as a separator, print the value of y. But if I have two variables that are strings and I do what looks like arithmetic, string plus a string just means concatenate the strings together, mush them together into one string. Let's do a few things with numbers. Now let's say x equals 15, y equals 30. Print x, y, and x plus y. 15, 30, and 45. What's the type of x? It's an int. What's the type of x plus y? It's an int, and so on. X used to be a string, now it's an int. Let's say x equals 15.0. What's the type of x now? It's a float. If I print x, y, and x plus y, what do I get? 15.0, 30, and 45.0. X was a float, we knew that. Y was an int, we knew that. And now when I do x plus y, it says an int and a float. I better make that a float. Okay, let's do type true. It's a Boolean. Let's change a few things around. Let's create a string that has the value true, and let's create a string that has the value of quote false. Okay, if I try and use these as Booleans, I can't because they're strings. Let's see, if I print x and y, I get true, false. But if I try and say, what's the type of x? It's a string. I can change it. Let's say I do Boolean of x, comes back with true. What's the type of Boolean of x? It is also a Boolean. Now, what else can I do? Let's create a real big integer. X equals lots of 8s. Print out x. Yep, lots of 8s. Let's say x equals 8 point lots of 8s. Print out x. It can only save about 15 significant digits. Let's say x equaled a bunch of 8s before the decimal point, and then a few after the decimal point. Print out x. Now it's doing it in scientific notation. It didn't lose the fact that there were lots and lots of 8s before the decimal point. But it can't save more than 15 or so significant digits, so it says this is the value 8.8 times 10 to the 44th. Okay, that should give you an idea of a few things that you can do with variables in Python. We're going to do a lot more in the future, so you're ready for lesson 1B.